Currently, our landscape is threatened by risks in the form of climate change and the related extreme drought. If we want to fight these threats, it is necessary to prevent excessive carbon emissions into the atmosphere and simultaneously retain as much water as possible in the landscape. Carbon itself, in the form of so-called biochar, can help us with all this.
Basically, biochar is a form of activated carbon, sometimes translated as biocoal, produced by what's called pyrolysis or thermal decomposition without oxygen. The advantage of this material is, of course, that it is very porous and has a high reactive surface. Its surfaces are around 500 square meters per gram.
High-temperature biochar is made from pellets that are crushed for this purpose, with unsuitable parts, especially iron metals, being removed. The pellets are then dried because they are exposed to ambient moisture. The heart of the technology is two-stage generator, where the main products are electrical energy, usable heat, and high-temperature biochar.
In a normal case, when these heads get burned or rot, a massive leak occurs. Carbon dioxide into the atmosphere. When pyrolysis technology is used, this doesn't happen. That CO is converted into solid carbon, which is then used as a blast furnace activator. An interesting number is that in the production of one charm, we remediate approximately 3 tons of CO2.
Biochar is made from various waste materials, not only from pellets and wood chips. The sludge processing technology is also interesting.
In this image, we see the functionality of the biostrip, in this specific case using quartz sand, when in this column it is the same quartz sand with the difference that it contains 3% biochar, and we see increased water retention, and additionally it also cements the mass itself. Of course, we can support the presence of biochar in the soil, in this case specifically an increase in mycorrhizal colonization.
Biochar not only retains water and nutrients in the soil, which positively affects production, but it can also absorb various contaminants from the soil, such as heavy metals. And how can we apply biochar?
We can apply biochar in its, let's say, raw form, either as large pieces like these, or let's say as dust particles. However, the disadvantage is that it's a dusty, lightweight material and essentially acts as a so-called soil conditioner without adding nutrients to the soil. This material can be mixed with conventional organic additives, such as compost or manure, which of course ensures the nutrient component. The cherry on top is then the production of roof substrate as part of greening urban areas. Thanks to the fact that it is a lightweight material, the resulting roof substrate is actually lighter, meaning it puts less strain on the building structure, and at the same time, it beneficially increases the aforementioned retention capacity of the resulting substrate, both for water and nutrients. Another sort of potential biochar products is the production of such pellets, actually containing manure, or other organic fertilizers like guano and vermicompost. An excellent way to get biochar into the soil is by mixing it with waste biomass, and then we can shape this paste either in the form of such, let's say mats, where we can, for example, even stick grass seeds, thus creating a kind of carpet that we can spread over the area we want, then grassing over, possibly creating these kinds of flower pots, with the benefit here of replacing conventional plastic ones. The whole story is about buying a plant in this kind of pot, and as you purchase it, you place it into the ground, thereby reducing transplant shock.
After using biochar in its various forms, it proves to be a very simple and at the same time effective solution to improve the quality of our soils and simultaneously retain the increasingly scarce water, both in the countryside and in cities.